We know that continuous innovation and technology is the true engine for launching quality products on the market. For an area as important as brake safety, which processes come into play in order to ensure an effective response prior to their launch on the market? Today, we will show you what tests we run on our brake pads in order to achieve more efficient reactions in high-risk situations behind the wheel. In this area, we basically do all the dynamic tests to check the brake pad's behavior in terms of performance, comfort, noise, etc. The main features we are looking for include the friction coefficient, and we therefore conduct a series of tests varying different factors, such as speed, pressure, temperature, etc. in order to know how a brake pad will react at all times, trying to simulate normal vehicle operations, while also subjecting them to extremely rigorous tests at levels that would never be found on the street. In terms of temperature, we can easily get them up to 800 degrees Celsius. We can get the brake disc red hot, which would usually be unlikely to occur under normal operating conditions. We have a machine that makes three-dimensional scans of materials, including our brake pads and all their components. Through this process, we can see if they meet our standards and our tolerance plan. Each manufacturer uses their own formula. We use a series of formulas depending on the car's cylinder capacity, sizes, and a series of inertias. For each vehicle, we also analyze the components or types of materials necessary for that specific brake pad. I think we must be world leaders in that area. We analyze over 300 brake pads and turn out approximately 180 new references per year. We must be the biggest, if not in the world, at least in Europe. The friction material is usually composed of 25 other materials. They are required to pass very rigorous quality tests, including chemical and physical tests. In this case, the physical test for granulometry control is to determine the quantity and different sizes of the particles. Regulations require the resistance to be double the maximum torque the brake pad will experience inside the vehicle. And fortunately, our brake pads allow for twice the value of this requirement. What the machine does is cut the brake pads and calculate the force they can resist. Regulation number 90, dating back to 1992, became a mandatory European directive starting in 2001. This directive requires replacement brake pads to have characteristics similar to the original equipment. That means an established range of more or less 15%, and that the replacement brake pads cannot break more or less than the original equipment. Lastly, the regulations also establish a requirement for manufacturers to control production. In other words, one thing is what is certified based on certain prototypes or product samples, but then we have to verify that the entire production meets the same requirements. In order to research new materials and check the quality of the manufactured brake pads, in addition to thousands of tests conducted in test banks and laboratories, as we've seen, rigorous tests are also conducted on the road. Next, we will show you some tests done at the Roadhouse Rolling Laboratory.